We will now continue our walk through the Pecos D Fee number 2 core, focusing on the upper part of the core. So if you're watching this as a standalone video or as a reminder, we're looking at the Pecos D Fee core. That's the one highlighted by the blue box on the right here and the blue dot on the map on the left. This is a core that has two intervals. We looked at the one in the siliciclastic dominated interval before. Now we're looking at the one on the carbonate dominated interval at the top in the Wolfram B. So here's the well log for the Pecos D Fee well. Gamma ray again on the left, the sonic on the right with the red curves. The two chord interval highlighted by those hatch box on the side of the depth track here. So we just look at the bottom part here with the low gamma ray 2 peak down here about 11,000 feet depth, stack of sandstone turbidite, and now we're going to focus on the upper part, another low gamma ray zone with lower sonic, and this is a more carbonate rich interval that we walk through. Now if we focus on the well log interval that corresponds to the upper chord interval, again gamma ray on the left, sonic on the right, we can see here on the right side of the slide Ian's chord description. So in the gamma ray we can clearly see 3 low gamma ray peaks there that seem to correspond pretty well to the free interval of carbonate in that chord. Look at the chord description now on the right. We start with some thin carbonate bed and then a 10 feet interval of siliciclastic mudstone. Then we have some muddy carbonate bed for about 15 feet, little siliciclastic mudstone interval, and then some more carbonate, and then we transition into this about 15 feet thick zone dominated by carbonate conglomerates, and then the rest of the core is all siliciclastic mudstone. If we look at TOC content, this is as previous example, up to 1 to 2% TOC in the mudstone interval, low TOC in the carbonate interval. For the clay content, you have up to 18-20% in the siliciclastic mudstone, maybe less than 5% in the carbonate. The XRF curves follow nicely the lithology with silica and aluminum in the mudstone, and carbonate and calcium and magnesium high in the carbonate interval. So here's a photo montage of the core boxes for the entire 60-foot interval that is scored in the upper part of the Pecos D Fee interval. If we look again just at the color of the rocks here, we can see we have about 10 feet of dark interval, probably mudstone at the base, then about 10 feet of a tan greenish interval, more mudstone for a little bit. Then in the middle of that photo here, we have about 15 feet of carbonate conglomerates. We can see the clast on this photo with darker muds in between, and then this interval is capped with about 20 feet of siliciclastic mudstone. So if we think back about the gamma ray curve, we can already see those two large low gamma ray zone in the well log probably correspond to those light color interval. So let's look at what the facies and the core looks like next. The first couple of boxes of the Pecos D Fee carbonate dominated upper interval start with a few tan bed and then some rubbly core, mostly made of siliciclastic mudstone. So here's an enlargement of that first tan bed at the bottom. We can see a big crinoid fragment floating into this tan silty carbonate matrix. If you put acid on it, it fizz, but you can clearly see there's some quartz silt in it. Then we have another silty carbonate wax stone, and then here's an enlargement of that piece here, which is a matrix supported carbonate conglomerate with semi-angular carbonate piece and some evidence for soft sediment deformation. So this is interpreted as a cohesive flow, a debris flow, a muddy debris flow. Above this we have about 6 or 7 feet of siliciclastic mudstone, pretty rubbly, core is in poor condition. Before it was that rubbly, Ian managed to take a thin section through it. Here's a photomicrograph of this mudstone. See a lot of clay and silt size quartz grain in it. There's a faint laminae in this thin section. Above this mudstone interval, we have about 7 feet of this crinoid wax stone, large fragment over 2 millimeters of crinoid, so we should really call that a float stone. The matrix is tan to greenish to yellowish, probably indicating a fair amount of clay in there and maybe some silt. This is typical of those slightly cohesive flow. Pretty massive. The matrix is a bit cohesive. They can be called slurry flow or carbonate debride. This is not a conglomerate though, but it behaves a little bit like it because of the cohesiveness of the matrix. So grading upward from those crinoid wax stone, we see an interval with similar facies, except this seems to be very heavily bioturbated. So on this close-up view, we can see the sediment has been reworked, probably by bioturbation, and we still see fragments of crinoids, but maybe not as big as before, sitting in this tan matrix. Now the mixture seems to be a little bit more homogenized. If we look at the fin section, we can see on the fin section that the matrix in which those carbonate bioclasts are floating is made of sealed to very fine grained sand, and in between those quartz grain a clay-rich mudstone. The top of that unit is an enlargement here on the right. Is again crinoid floodstone, seems to be less disturbed by bioturbation. It's capped by this dark matrix floatstone, and then grade upward into siliciclastic mudstone. So probably this entire interval is just one big gravity flow, 8 to 9 feet thick gravity flow that is a somewhat cohesive flow, and in the muddy matrix and silty muddy matrix, maybe reworking some of the sediment on the slope. Clearly the bioclasts are from the outer shelf, upper slope, where the crinoids live. Nothing else, no fusillinid, a few shells of brachiopod and other bivalves can be found here. So we'll be tempted to interpret the entire stack as a one big slurry flow. And we got 2 feet of siliciclastic mudstone, quite fissile as you can see. And then the enlargement here shows the next carbonate flow. It starts with the matrix supported carbonate conglomerates, grade upwards into crinoid floatstone, similar to what we see before with the argillous siltstone matrix, and a high density of finer crinoid fragment upwards. That flow is not too thick. I think we can break it after by a foot, where that little arrow here is. There's a muddy layer here, and then we start the next flow. After that, we have the next flow with the base here, this thin section showing again high amount of silicified quartz in the matrix and some bioclast that seems to be oriented into that wax stone. And then further up, the next thin section shows a bigger crinoid fragments sitting in the more clay-rich matrix here, still with some very fine-grained sand and silt. These beds continue until we see here on the enlargement the evidence that we're starting to have big blocks here in this little carbonate conglomerate wedge here. So that slurry flow probably end and it's immediately covered by a debris flow, or that big 3.5 feet block is just what it is, a block, and what we interpret it as a flow is just 4 feet blocks floating in that large matrix to supported conglomerate. Anyway, this is the first indication that we might be in a large debris flow with big blocks. And then further up we have this thin mud layer in our incline that is capping a little grainier part of the flow, so that could be the top of that one conglomerate. Otherwise we have to go to that fissile siliciclastic mudstone right next to the arrow here, or further up to find the edge, the top of that conglomerate and that debris flow. So we move up a bit. Now we see clearly the top of that conglomerate capped by those siliciclastic mudstone. Thin section here shows the matrix in between the block, which is made of clay-rich argillaceous siltstone with quite a bit of carbonate fragment forming that matrix. That second thin section right at the top of the debris flow has been taken inside one of these blocks. We can see the edge of a peloid grain-dominated packstone here, and again the matrix, which is clay-rich bioclastic with some fusilinid. Above the debris flow then we have almost 25 feet of core that consists of siliciclastic silty mudstone. Clay content is about 18-20%, TOC just about over 1.5%. Not even any dilute turbidite. It's a pretty clean pile of mudstone here. So to recap, that upper part of the Pecos D Fee number 2, the carbonate dominated part, at the base we had a couple of blocks of carbonate, and then an interval of siliciclastic mudstone, then about a 10-foot thick interval of slurry beds which were made of crinoid waxstone with the matrix made of silicified quartz and some clay in it. Here on the core description we say about a couple of percent, 5 maybe percent of clay in this interval, then another little layer of mudstone, some more carbonate bed, and then a carbonate debris flow that we interpret that was about 15 feet thick, and then capped by 25 feet of carbonate mudstone. We can clearly see here on the XRF data how the silica and aluminum correlate very well with the mudstone, and then the calcium with the carbonate beds, a little bit more magnesium in the slurry flow at the base because it incorporates more probably of the matrix in it. So here it is for that core. Let's move on to the next carbonate core.